Thank you very much, Steffi. Great to be here and to talk about quantum. The next days we go beyond. We dig deep into latest innovations and frontier tech. And among these topics definitely is quantum computing. And if you allow me to say, potentially the hottest topic. When I was 14, I read a book called In Search of Schrödinger's Cat. And actually, it blew me away. Without really understanding the deep mathematical foundations yet, I knew if this is all true, we had to dramatically change our worldview, away from a materialistic towards a holistic view of things. With quantum technologies, we are standing on the shoulders of giants. It were brilliant minds like Schrödinger, Einstein, Heisenberg and Planck who laid the foundations of early quantum mechanics almost 100 years ago. They researched the groundbreaking principles of quantum mechanics. Among them, there's one which is called the wave-particle dualism. Every particle can be described as a wave, and every wave can be described as a particle. The first quantum revolution started. So, what are these phenomena? And I make it really quick. Quantum superposition. Whereas in the classical world, every object has a distinct nature, either being 0 or 1. In the quantum world, every object can have any value in between 0 and 1. It exists in a superposition of all potential states. Quantum entanglement. Think about a pair of two objects entangled. I bring one object into one end of the universe and the other object into the other end of the universe. And now I change a parameter on that one object, and immediately that other object recognizes it and changes its behavior. Instantaneously, those two pieces are connected. Einstein called this the spooky long-distance effect. So what can we do with these principles today? Well, the two principles put together helps us to create a machine which shows an exponential speed up of compute power. Think about that, an exponential speed up. I think it's the only business where the underlying trend is the exponential function. The exponential function sooner or later overtakes everything, outperforms everything. That's why people are so excited about quantum. And today, we know how to build and use these machines. The second quantum revolution. 2019, I founded Terra Quantum to bring quantum technologies out of the research lab into industrial applications. And at Terra Quantum, we have one clear mission: to provide meaningful quantum solutions already today. So you might ask, why don't we find then vast amount of large-scale quantum applications implemented across industries? Well, actually, there is a challenge. The quantum hardware isn't mature enough yet. We need more time to build the hardware so that it doesn't have so much noise and errors. But is that a problem? Well, it's quite typical. If you look at the Gartner hype cycle, which is true for almost every deep tech discipline, after a phase of hype and excitement, the technology falls into a valley of disappointment before it reaches a plateau of productivity for industrial applications. Quantum is actually almost at that peak. So what does that mean? Do we have to wait the next 5 to 10 minutes? That will be good. The next 5 to 10 years to do something meaningful with quantum? The question actually is, how do we bridge between the hype and true universal quantum computers? And there is a solution. The solution is hybrid quantum computing. Hybrid quantum computing will bridge the gap. Hybrid quantum computing actually will be the heating technology which makes us survive the quantum winter. Hybrid here means we simulate qubits on a classical high-performance computer, we enhance it with early available native quantum chips, we deploy our quantum software, which we can build today on such hybrid environments, and by doing that, we unlock some of the quantum potential already today. We recently published a benchmark paper where we holistically analyzed the performance of various quantum devices, native quantum chips as well as simulated qubits, and we could show that this hybrid approach is superior not only vis-à-vis the early stage native quantum chips, but outperforms best-in-class classical implementations. As this still might sound a bit abstract, let's illustrate the superiority of a quantum algorithm vis-à-vis a classical algorithm by an example. Think about the near-term Alps, and I give you a task. Please find out what is the highest peak in the Alps. So how would you do that? Well, actually, you would have to run up the hills sequentially, one by one, measure the altitude, and report it back. So it's a lengthy process, and you'll never be sure whether you found already the highest peak. Think in contrast how quantum does it. Think about a large blanket overarching the full mountain range falling from sky. As soon as that blanket reaches the highest peak, in that case, the top of the Mont Blanc, it will report back, I found the highest peak, we can stop the exercise, we are ready. It's much dramatically faster and more accurate. That shows you the superiority of quantum algorithms versus classical algorithms. So what can we do with hybrid already today? Let's quickly look into two cases. The energy sector. Quantum computing can do a big deal for the renewable energies. The growing number of solar panels and windmills creates a growing volatility which is hard to integrate into the energy network. Quantum computing helps to predict such capacities and stabilizes the grid. One more, healthcare. Today, the development of new drugs heavily depends on your ability to simulate on a classical high-performance computer. Quantum simulation will dramatically speed up that process. Quantum simulation will also help us to understand the human body on a much more granular level. This helps us for customized treatments and personalized medicine. Ladies and gentlemen, today I would like to leave you with one clear message. Quantum technologies have left the research lab. They have arrived in industrial applications. Ladies and gentlemen, quantum is now. Thank you. And now I'd like to welcome Dr. Zina Cinker on stage, Director General, Meta. Together, she is a physicist herself, and together we'll dig into the quantum applications and what impact quantum has on business and society. Zina, welcome.
Do we do this?
Thank you.
We did it without messing our microphones up. I'm going to sit right there. Hello, everyone. Markus, it was only 2 months ago we were sitting on my stage in Barcelona at PuzzleX, right? And talking about quantum. The frequency of these conversations are really giving me hope that we are getting closer and closer to us highlighting the potential of quantum and the quantum movement. But to fire up this fireside chat, I'm going to ask you a question. Can I be candid with you? Can I be candid with you?
Oh, yeah, absolutely, please.
Will you allow me to challenge you?
Please.
Okay. You talked about quantum. Why should I care? And let me just do a role play. If I am, I don't know, Jane, what's her name? And I work in the financial sector, or I am John Doe and I work in energy or logistics. What does that have to do with me? Why should I care about quantum?
Yeah, So to start, actually, you mentioned financial services. We work for financial institutions. To give you an example, banking is all about optimization and simulation. We work on a case called collateral portfolio optimization, which can be optimized with quantum much better. We save that bank already a 200 million euro annual recurring cost by migrating that collateral portfolio optimization into the quantum space. That we can do today, but one more potentially more crucial example is security. You know that every classical encryption code will be hacked by a future quantum computer of enough size. So all encryption protocols, all exchange of confidential data has to be upgraded to a quantum secure level. We recently read about the work of the Chinese. There's a lot of buzz going on, but one thing is sure, you have to be quantum secure before the hardware is mature enough. Once the hardware is there, you are hacked. So therefore, the implementation of quantum security protocols is something which you should care today, and we do so, and we work already and implement our own QKD protocol with various clients.
So we should care about quantum. And we've got 2 or 3 days in front of us that people can dive a little bit deeper into that with you. You showed the Gartner hype cycle. You know, I come from the graphene background, so if there is one field in the past 15 years that has seen the Gartner hype cycle, and I used to run the trade association for graphene for North America, I have lived it, I've tasted it, I've been punched by it. Is winter coming for quantum?
Probably winter is coming, but it will be a warm winter. Because I get you, the Gartner hype cycle is very typical, and quantum is no exception in many aspects. But there's one great thing: we found a solution to bridge the gap, to heat up the winter, and that is hybrid, where we can do great things.
Fantastic. So we've got a solution guiding us through that. You talked about use cases. I know that so many people think that the use case of quantum are very much far into the future. Are there use cases you would like to tell us about that is happening right now?
Yes. You know, in general, I could talk a lot about it. Financial services will see, after the quant revolution in the 80s with the structured products, a quantum revolution where we quantum enhance Monte Carlos and all those structured products. But two specific different industries. We work for Thales, which is the large European aerospace company, and we do satellite mission planning. Those Earth observation satellites have to be guided very carefully to make the most out of it, to make the best use. Where should they do pictures to generate maximum revenue? And by quantum enhancing it, we add additional revenue potential in the order of a 3 million digit number. So that's big. That's what we do today. And then Uniper, one of the large global energy providers, we work on various cases. We do CO2 prediction for biomass power plants to better utilize the biofuel. We work again on quantum speed up the Monte Carlos for energy trading. But very importantly, especially for Europe, is LNG shipping logistics. That's one of the crucial strategic topics these days for Europe to secure energy supply. And you might think, well, 4, 5, 6 of those LNG ships, what is quantum about this? Well, if you drill down deep to how fast should they go, how should they be orchestrated, how much fossil fuel you burn, it's a very complex task, and we work on to quantum optimize those logistics together with Uniper.
Quite interesting, and we're talking about now, what is possible now, and everybody who knows me knows I'm obsessed about the future. So let's do this exercise. Let's travel into 2040. And we're sitting on this stage again. We're back to DLD, and we're sitting on, I'm looking much older. You're just looking as dapper as you do right now. Let's think about that. What does that future look like? What is the impact of what TerraQuantum and the quantum movement has had on the lives of citizens and our societies? The true impact. How have these lives changed?
I think this will dramatically change all of our lives. It will disrupt and impact almost every industry. But to name one specific industry again, let's look into the healthcare sector. So we developed a field effect transistor with negative capacitance, which will make it possible to create a chip the size of the human DNA.
It's magnificent.
Think about that. I mean, this will augment the brain. We will move away from binary, von Neumann logic towards neuromorphic computing. Very exciting case. Again, the design of new drugs and vaccines, that will be speeded up with quantum simulations to make it very fast and will help us a lot. Last but not least, again, the security issue within healthcare. How do we protect your individual healthcare data? We are working on quantum blockchains to secure, e.g., the vaccine delivery process from production towards the individual target. Just to mention a few.
That's fascinating. Looking to the future. And okay, so you said you would be candid with me. Can I don't even know if I should bring this thing up or not. But I've heard through the grapevine that you guys are releasing a white paper about my topic I'm obsessed with these days, is biology. As a physicist, I'm obsessed about biology and I know nothing about it. But are you okay telling us about it? And if you're not, it's okay. You don't hurt my feelings.
So that is when one talks to somebody who is very well connected in the quantum ecosystem. Indeed, we'll launch a business paper on quantum biology very soon. It includes some of these examples I mentioned, but much more, because the future of biology is quantum. So stay tuned.
Stay tuned. Okay, we're going to stay tuned, but this is going to be fascinating white paper, and I would like to be able to take a look at that whenever it is available. And we've got about a minute, so if we could just, one rapid question, and I want to emphasize the geopolitical implications of a very powerful technology like quantum. In this global landscape, how do we navigate this?
Yeah, I mean, this is a global race, indeed. We have to look at China, the US, and Europe. And let's focus here in this context on Europe. We're doing great things here already to create a vivid quantum ecosystem in Munich, the Munich Quantum Valley, so where industry, academia, and quantum tech startups work together. That's great. We need more of that. But I can assure you, we have to see that and aggregate it and orchestrate it on a European level to compete. We cannot afford, as Europe, to lose out on that breakthrough technology. And if you look through the value chain, it's great if you seed fund those things, if you do spin outs from academia, all good, all great. We need to have more of that on a European level. But we also should not forget, how do we then, it's again a gap, the financing gap between Europe and the US. We have to make sure that we not only create the next unicorns, but the next Googles, yeah, the decacorns as well. So we need the financing to protect us from selling out all these quantum technologies to other regions.
Fantastic. And to wrap it up, Markus Pflitsch, my friend, if you had to describe quantum with one word, what would it be?
Exponential speed up.
Fantastic. Well, I think it was a drop the mic moment. Thank you so much, Markus, for joining me in this conversation. We're going to be around for the next 2 or 3 days, so please join us. Quantum is a community, and we need you in it. Thank you. Thank you.
Thank you.
Thank you so much.